In this video, I want to give you a brief overview of SchemaSys, a tool that allows you to create domain-specific drawings, such as electrical circuit diagrams, that are directly based on SysML models. SysML provides a sophisticated language for defining complex structure. However, its generic block diagram visual syntax can be limiting. Sometimes it would make more sense to visualize the model, for example, as an electrical circuit diagram, or a circuit board layout, or a piping and instrumentation diagram, or a process flow diagram, or a fault tree diagram, or a network diagram, or a rack layout diagram, or even a track layout diagram. In fact, there are many specific engineering domains that have established forms of visualization, and it doesn't always make sense to resort to block diagrams. And while commercial off-the-shelf SysML tools do allow for some visual customization, they are not generally capable of handling the demands of domain-specific schematics. SchemaSys, on the other hand, is designed from the ground up to make SysML look any way you want it to. To illustrate this, I would like to take the example of a simple stereo amplifier. So let's zoom in here a little bit. This block in the middle, named TEA 2025, is an integrated circuit that contains the actual amplifier itself. The rest of the circuit is basically just there to connect the IC to its inputs and outputs. Here on the left, you can see, for example, the power input named VCC, and you can also see the signal inputs for the left and right channels, VN1 and VN2. Over here on the right, you can see the two speakers that serve as output, out1 and out2. In between are a bunch of parts that represent common electrical components, such as resistors, capacitors, and junctions. For example, R1 is a potentiometer, which is a kind of resistor. C1 is a fixed polar capacitor, and J1 is an electrical junction. The connectors in this model represent arbitrary electrical conductors, which could be wiring or could be conductive tracks on a printed circuit board. These kinds of internal block diagrams will be very familiar to anyone who has spent time modeling in SysML. But now I have a little surprise. If I double-click over here, then I can open up an electrical circuit diagram for the amplifier we were just looking at. This diagram is rendered entirely through SchemaSys and is therefore not bound to the usual constraints that apply to SysML block diagrams. Nevertheless, everything you see is linked directly to the model just as tightly as if it were actually a SysML diagram. So for example, if I click on R1, the property view synchronizes to show me the properties of R1. If I click on C1, then I can see the properties of C1 and the same for J1. If I select R1 and rename it to resistor 1, then the diagram is immediately updated to reflect that. I can also select elements like this, move them around, and as I will show you later on, I can add elements, delete elements, and basically do anything necessary to create diagrams from scratch. And of course, I can undo my changes like this. So in other words, SchemaSys diagrams are analogous to SysML block diagrams. But rather than constraining you to generic block symbols, they allow you to visualize the features of a block with arbitrary vector-based graphic symbols that you define yourself. These symbols are themselves defined as SchemaSys diagrams, which can be collected and stored in libraries for use across multiple projects. One thing I'd like to point out are the light blue arrows attached to the various symbols. Let's zoom in so we can see them a bit more clearly. Those arrows are actually connection points, and they provide locations for connectors to attach to. Notice what happens if I select the connectors to C1, like this, and then delete them. As long as the connection points are on, it's easy to see where the plus and minus poles are located. But as soon as I turn the connection points off, you can't really see where the ports are. Once the connections between elements have been made, the connection points aren't as significant because they are essentially implied by the connectors themselves. For example, the connectors to C2 visually indicate where the plus and minus terminals are. But for unconnected elements, like C1, I'll turn this back on so you can see, or elements that are only partially connected, like this junction, connection points are a key mechanism. Connection points solve a fundamental problem in schematic drawings, which is that parts and ports may exist on a diagram without actually having any particular visualization. By contrast, SysML specifies standard generic symbols for parts and ports, which cannot be altered. By giving you complete freedom in regards to what a part or port may look like, SchemaSys removes one of the barriers to linking schematic drawings to a SysML model. Another interesting point is the ability to place ports anywhere in the diagram. Let me switch over here. See, in SysML, ports must be located along the edges of the containing block. Here you can see that VCC, VN1, and VN2 are bound to the edge of the diagram and cannot be placed anywhere else. Likewise, ports of parts, like here, are bound to the edges of their parts. So for example, the terminals T1 through T4 are bound to the edges of the J1 rectangle. Electrical circuits, however, often have ports placed arbitrarily within the diagram. Here, you can see that VCC, VN1, and VN2 are not subject to any placement constraints. So before I mentioned the ability to define arbitrary symbols. Let me show you the Symbol Preview tab. If I click on R1, for example, you can see that there are 4 possible symbols for that element. SchemaSys decides which symbols to display based on the type of the element selected. For R1, the type is a potentiometer. So in this case, you can see that there are both IEC and IEEE style symbols, and that each style comes in a horizontal and a vertical variant. If I click on C1, by contrast, you can see that a different set of symbols is displayed. Some elements, such as electrical conductors, let's click on one of those, may only have one symbol associated with them, while other elements, such as this polar terminal, may have many symbols. As a result, placing an element on a SchemaSys diagram is a 2-step process. So first, you select the element itself, and then you select the element's symbol. Notice that SchemaSys allows you to place the same element more than once on the diagram. For example, here you can see that the ground element, G and D, has been placed many times throughout the diagram in accordance with electrical circuit drawing conventions. Finally, I would like to show you how a SchemaSys diagram might be created in practice. One way to do this is to begin with an existing internal block diagram. Let me open an empty SchemaSys diagram in a separate window. So we'll just open this. I'll put it over here so we can see both at once. Like that. So, if I click on an element in the internal block diagram, I can decide which symbol I want for the circuit diagram. So like that. And just pull that over. And let's do that for J1 and C1 this way. And for ground, and I'll just move that over a little bit, and we can connect these, connect this, connect these. And you can see that the geometric arrangement of parts and ports in the SysML view kind of provides a guideline for the arrangement of symbols in the SchemaSys view. So I think that's as far as I want to take things in this first video. But as I mentioned, I do plan on putting out more videos that go into detail on some interesting SchemaSys features. Be sure to like and subscribe if you want to be notified when those come out. And please do forward this to anyone who you think might be interested. Also, be sure to comment below, as I am very keen to find out if this tool addresses your needs. Clearly, there are many drawing programs on the market, but the key idea here is to directly link the modeling richness of SysML with the visual richness of domain-specific schematics. Does this strike a chord with you? Are you excited about this idea? Or is this out of touch with the way you use SysML? Either way, I'd love to start a conversation, so please do leave a comment below, and I'll see you in the next video.